So my name is Emily. I'm a software engineer on the Chrome security team. And I'm going to be telling you today about a protocol called TLS, which is used to encrypt communications between a client and a server. Quick straw poll before we begin. How many of you have sort of heard of TLS, maybe set it up before, kind of have some idea of what's going on here? OK, great, thanks. I just wanted to get some calibration here. So I'm going to start out by telling you a little bit about what TLS is and why all of you, every single person in this room, should care about it and be using it, how to get started with it, and a little bit about what modern browsers are doing to kind of push the web in this direction. So let me start by telling you that TLS stands for Transport Layer Security. And as I said, this is a protocol that's used to encrypt communications between a client and a server. You might have heard more about SSL than TLS. That might ring some bells. People often use these terms interchangeably, TLS and SSL. But as it turns out, TLS is actually the newer and less broken and more modern version of SSL. So technically speaking, you always want to be using TLS rather than SSL. When you type in a URL into your browser's address bar, and you see this HTTPS, google.com, and this green lock icon, that's the browser telling you that it has set up a TLS connection with the server, and it's sending your HTTP requests over that connection. So HTTPS is a way of saying HTTP requests are being sent over an encrypted and authenticated connection. What do you get from this encryption and this authentication? There are three concrete properties that TLS gives you. The first is no snooping. So when you are sending traffic from a client, like a web browser, to a server, the TLS protocol being used to encrypt communications between the client and the server is preventing an attacker from sitting in the middle of that connection and eavesdropping on the data that's being sent between these two parties. Second, no tampering. This attacker who's sitting between the client and the server might be interested in doing more than just eavesdropping. The attacker might be messing with the data that's being sent in between to try to send false data from the client to the server or suspect content from the server to the client. If the attacker tries to do this over a TLS connection, one of the parties, the client or the server, will detect the tampering and close the connection. The third property that TLS gives you is no impersonating. This means that when you go type https google.com into your browser, you know that you're talking to a google.com server and not an attacker who's impersonating Google. And you know this because the server has presented a cryptographic proof of identity, proving that they are the website that you meant to visit. So these are the three properties that TLS gives you: no snooping, no tampering, no impersonating. And you might be thinking, this is all well and good for Google or Amazon or Facebook, sites where people are exchanging money and posting sensitive content and doing all sorts of important things. But maybe your site is just for serving pictures of cats or something, and it's not really that important to you that your users' traffic on your site is secure. I want to convince you that that's not true, that if you're building a production web application, you should be using TLS. First, I hope to boost your self-esteem a little bit, because the activity that users do on your site might be sensitive to them, even if you don't think it's important to them. So my point here really is that you shouldn't be deciding for your users whether their activity on your website is sensitive or not. You should give them the choice of browsing securely so that they can decide whether their content is sensitive. Some people sometimes look at a website like the New York Times, which is for reading news. And I'll note that the New York Times does not currently have TLS enabled, though it is on their roadmap. And the reason it's on their roadmap is because reading the news can actually be extremely sensitive browsing activity, depending on the user and the context. For example, if you're reading an article about gay rights activism in an oppressive regime, Or you're making decisions about buying or selling huge amounts of stock based on the news that you read. So these are cases where it's actually very important that the news that the user sees is the real news, and that the user is able to read the news without someone sitting in the middle seeing exactly what they're reading. So TLS is good for your users if you're running a production web application. It turns out it's also great for you as a site operator. There are many reasons for this. One is that suppose you're trying to monetize your site that serves pictures of cats. Maybe you're doing a subscription model for special pictures of cats, or you are putting ads on your site to try to generate some revenue. It turns out that this monetization strategy is going to work best if your users are actually seeing the content that you expected them to see, that finely crafted UX that you spent hours perfecting, or that perfect subscription flow that maximizes conversion. You don't want an ISP or a malicious or self-interested third party messing with the content before it gets to the user. And this happens in real life. Here we are on the New York Times again, reading about capital in the 21st century, when we notice that something doesn't quite look right. There's a really ugly Southwest toolbar because we're on Southwest Wi-Fi. And the New York Times puts a lot of effort into their design and their UX, and they probably don't want this Southwest toolbar covering that up. This is just because we are connecting to an insecure HTTP site on Southwest Wi-Fi. And this would be even worse, as you can imagine, if it was covering up ads, for example. Another reason I want to mention why setting up TLS is good for you as a site operator is that companies are starting to incentivize it. And a great example of this is Google bumping up HTTPS pages in search results. So if you turn on TLS, you'll get a search ranking boost. It's good for your users. It's good for you as a site operator. It's also the direction that the web is moving as a whole and that browsers are starting to incentivize. I'm going to tell you 2 ways in which this is true. First, there are some shiny, new, powerful web features coming out. Geolocation, full screen, notifications, service workers. All this cool new functionality is so important and so powerful that browsers prompt users before they give websites access to these features. So there's that, anytime a website tries to access your location, you'll see a notification from the browser asking you if it's okay if this website uses your location. Pretty soon, websites will only be allowed to use these powerful features if they are served over secure connections. The reason for this is that no impersonation property I was talking about. If the browser is going to grant access to a user's location or other powerful functionality, the browser needs to make sure that that access is being granted to the website that the user intended to grant it to, not some random attacker who's sitting on the network taking advantage of that capability. So this is why browsers will soon be deprecating access to these powerful features unless your site is served over TLS. Going even further in this direction, browsers are working on deprecating insecure HTTP altogether. And you can get a glimpse of the future by turning on this experimental Chrome flag, where you can see non-secure origins marked as non-secure. What this means is that if you go visit an insecure HTTP site like the New York Times, instead of getting a neutral indicator, it'll get this broken insecure indicator. The goal here is to make it so that the web is secure as the norm and insecure as the exception, because we want users to notice when they are on an insecure site. It shouldn't be neutral, it should be broken because it's insecure. It's completely insecure. So we're not here yet. This isn't today or tomorrow, this is the future. But it's the direction the web is moving as a whole, and we should all be using TLS to encourage our users to expect security as the norm so that we can build up more TLS sites, increase support and tooling around them, and make it so that that's what users expect on the web. All right, hopefully hopefully I have convinced you that TLS is what you should be using if you're putting an application into production. I'm now going to step off the soapbox and just tell you more practically how you get TLS set up on your website. The first step is to get one of those cryptographic proofs of identity that I was talking about. So when you're running a website, you need to get what's called a certificate to prove to clients that you are who you say you are as a website. You can get these certificates for fairly cheap, about $10 a year, same kind of order of magnitude as buying a domain or setting up a server. There are many companies you can buy them from. Namecheap and SSL Mate are a few that have inexpensive offerings. And coming up in September is a project called Let's Encrypt that will actually offer free certificates and really cool tooling around them. When you are going to purchase your certificate, I recommend that you get what's called a 2048-bit key, so that's the size of the cryptographic key. You should get at least 2048 bits for modern secure standards. Unless you have a particular reason to think that your site is particularly security sensitive, I would recommend that you don't go higher than 2048 bits because you might start to see performance implications. One other thing I want to mention is that you might need more than one certificate because a certificate is tied to a host name. So if you're serving example.com and www.example.com, you'll need a certificate for both of those names. Or you can buy what's called a wildcard certificate, which is much more expensive, but will cover star.example.com. So that could save you from having to buy a whole bunch of certificates. Now that you've gotten your certificate, you need to go set it up on your server. And that entails uploading your certificate and private key file and making some changes to your server's configuration. I want to put out a big warning here that it's actually very easy to do this incorrectly. And it used to be actually quite hard to get TLS set up because it was so easy to do it incorrectly. Fortunately, we now live in a world where there are some great tools coming out that help you do it properly, and even more coming in the near future. I mentioned SSL Mate as a place where you can buy a certificate. They also make some very easy command line software that will help you set up your server. So for example, you will go run this software on your server, and it will spit out some changes to your Apache or Nginx configuration files and guide you through the process of getting set up. If you buy your certificate from them, they will even have their command line software automatically renew your certificate when it's time. Another tool I recommend is the Mozilla SSL Configuration Generator. And this is a web-based tool where you just go plug in some parameters about your website, and it will spit out configuration file changes to make to your server. So these are great ways to make sure that you're setting up TLS with the correct parameters with modern security and not getting it wrong. How do you know if you have gotten it right or wrong? SSLLabs.com. You go there, you give them the URL of a website, and they will kick off an analysis of that website and spit out a grade. So this is sort of an overall rating. You can get an A+, an A-, a B, you can get an F. And this will tell you why it gave you that grade, what you can be doing better, what cryptographic parameters you chose that might have been good or bad choices. And it'll also tell you if you're susceptible to any of these new attacks on TLS that come out every few months and how you might be able to mitigate them. I want to point out something about SSL Labs that is both frustrating but actually quite good. You might go set up TLS on your website and run SSL Labs and get an A or an A- or a B or some grade that you're happy with. Then you think you're done, and 6 months later, you come back and you run SSL Labs again. And 6 months later, you might have a C or a D or an F. And the reason is that things are constantly changing. There's constantly new attacks and mitigations, new developments in cryptography and security. And it's important to keep abreast of these because unfortunately, TLS is not fire and forget. There is a maintenance effort. And SSL Labs can help you keep up with that maintenance effort. So it should be something that you run regularly and pay attention to instead of something that you just run once and assume you're good to go. I think that about covers how you configure your server to serve your site over TLS. There are a couple of things that you need to know about your application, though, because if your application is doing something wrong, you can actually compromise the security of your whole site. So I'm going to point out a few common pitfalls and how to fix them. The first is a problem called mixed content. In a nutshell, mixed content is where you're serving an HTTPS site, but some of the sub-resources on that site are served over insecure HTTP. What you need to do is actually go update your absolute URLs to point to HTTPS versions of those resources. If a resource is available over HTTPS, you should be retrieving it over HTTPS. So what happens if you don't do this? If you have this problem called mixed content, which is where you are serving insecure resources on an HTTPS page, this problem can manifest itself in compromising the user's security, and browsers will help users notice that by downgrading the security UI. So this is one example of that happening, where we have a website that's displaying an image that was retrieved over an insecure connection. In this case, the browser shows that sad yellow lock icon instead of the nice green lock icon, and actually warns the user that they are displaying resources which are not secure. This is what's called passive mixed content, when we're sort of displaying insecure resources. If you actually try to run insecure resources, so for example, load a script over an insecure HTTP connection, or a plugin, or an iframe, or any type of more active content, modern browsers will actually just block that content from running, and users will have to go make a positive action to allow that content to run. So if you try to run a script over HTTP when your site is served from HTTPS, it can actually end up with your users having a broken experience. So this is why it's important to go update your absolute links to point to HTTPS versions of your sub-resources, avoiding mixed content. Let's talk about cookies, which are, for many of you, probably among the most sensitive pieces of information in your application, because your cookies probably include a session ID or session token, something that can be stolen and used to take over a user's entire account. Wouldn't it be great if there was a way that you could tell the browser, this cookie is a particularly sensitive piece of information, and I only want that piece of information to be sent along with HTTPS requests. So even if a user somehow ends up sending an insecure HTTP request to my site, don't send that cookie with it, because it's too sensitive to send in plain text. This is exactly what the secure attribute does on your cookies. So when you set this secure attribute on your cookies, the browser will refuse to send it except over an encrypted connection. And this is a must-have for production web applications. If you're serving your site over TLS, definitely set this secure attribute on your cookies to protect your users' accounts. I have another, what if it wouldn't it be great question. Imagine that you are a user and you go to http://yoursite.com. So there's a user who is visiting your site over insecure HTTP. And you want your users to visit over TLS. So you're probably serving a 301 or 302 redirect to send users to the HTTPS version of your site. What would you do with that if you were the evilest attacker you could imagine? You would probably intercept this 301 or 302 redirect that's served over HTTP. You would just intercept that and replace it with whatever malicious content you want. As an attacker, if you have the ability to stop a user from visiting a site over TLS, you're going to jump on that. What this strict transport security header does is it stops the browser from sending that request over HTTP altogether. Once the browser sees this strict transport security header on your site, the browser will forevermore, or at least until the header expires, stop sending users to the HTTP version of your site and send them straight to the HTTPS version. So when you're taking your site to TLS, set this header to make sure that users always visit over HTTPS and not over HTTP. I think by now you probably understand that I think TLS is great and that we should all be using it for all our production applications. But practically speaking, it's not a panacea. And it doesn't protect you from everything. And I think it's important to know what the threat model is and what it does and doesn't protect against, just so you don't give your users a false sense of security. First, unfortunately, you still have to worry about all your classic web application security bugs. Cross-site scripting, cross-site request forgery, all of these have their own defenses that we all need to be worried about. But TLS does nothing to protect against these types of bugs. And it's also important to know that TLS doesn't protect everything about the traffic that is going from a client to a server. What I mean by this is that if you go type https amazon.com in your browser, an attacker on the network can trivially tell that you are visiting Amazon. An attacker can see the timing of your traffic and some things about the size of your traffic. So a good way to think about this is that an attacker will have a hard time telling exactly what you're buying on Amazon, though they might be able to learn something about what you're buying just from observing traffic timing and size and comparing to known fingerprints. But they're going to have a harder time figuring out what you're buying. They're going to have a very easy time figuring out that you are visiting Amazon. To sum up, the takeaway here is that if you're running a modern web application and putting it into production, I think that you should have TLS on your checklist right next to buying a domain, setting up your database, setting up your server. All those production checklist items should include TLS. It's good for your users, protects their privacy, allows them the power to choose if their activity on your site is sensitive or not. It's good for you as a site operator, helps protect your monetization strategy and help ensure that users are getting the content you expect them to. And it's good for the web and the ecosystem as a whole. Thank you.